Hi, this is Mrs. Finnegan, and we're going to be looking at polynomial and rational functions. We're going to be starting with question number 30. So what we're going to do here is we're going to graph a polynomial using some characteristics that we can get from the equation and that we can solve in order to graph it. This is very similar to the problems that we did over in problems 6 through 11 at the beginning of the review. So remember, the first thing that we're going to look at is identifying the basic shape, and we get that from the lead term. Our lead term here is x cubed. Okay, and remember, we're looking for the degree and the sign. So in this one, it's an odd degree, means our ends are going to go in opposite directions, and because it's positive, we know that our ends are going to increase going from left to right. We're not really sure what it's going to do in the middle, but we know which direction the ends are going to point. Okay, our y-intercept is going to be the constant term at the end, so that's going to be 6. Next is possible rational roots. In order to identify what potential values could be roots or zeros for our problem, what we're going to do is we're going to create a ratio of the factors of our constant term, which is 6, with the factors of the lead coefficient, which in this case is 1. Notice we have, it could be either the positive or negative form of that. So I'm going to take my 6, I'm going to identify all the factors that it could have. So 1 is always a factor, 2, 3, and 6. All right, and then the only factor of 1 is 1, so that makes it a little bit easier for us. So if I was to break this apart, I would have 8 different possible roots or zeros or solutions. Again, these are where we're crossing the x-axis. So I'm just going to list them from least to greatest. So I have 6 over 1. Since everything's being divided by 1, I just have those whole number values. So -6, -3, -2, -1, and then 1, 2, 3, and 6. All right, so why this is important, this is going to help us determine what values we're going to use in order to find our factored forms and our zeros. And in order to do that, we're going to use synthetic division. So I already have this one set up. Synthetic division, remember, we're going to create this little division symbol, and we're going to take all of our coefficients of our equation and write them in order. Now remember, if you're missing a term, let's say I didn't have the x squared term or something, you have to replace that term with a coefficient of 0 to hold its spot. So 1, -4, 1, and 6 are going to be written down here. Remember, we always bring down the first term and do nothing with it to start with. But what we're going to do is we're going to pick one of these possible roots as our 0 on the outside. Remember, we're always using the 0 in synthetic division as opposed to its factored form. So I think that you're going to take a guess. If you don't get it right, you can always just try again. I'm going to guess that since this is a positive 6, I'm probably going to have something crossing over in the positive side. So I like the number 2 just because I have a lot of even numbers here. So the first number drops down. Then we're going to multiply our 0 on the outside with the number on the bottom. So 2 times 1 is 2. I'm going to write it in the next column. Now I'm going to add these two numbers together. So -4 plus 2 gives me a -2. Okay, so I'm going to repeat the process. Multiply. 2 times -2 is -4. And then add. 1 minus 4 is -3. Last time, 2 times -3 is -6. 6 minus 6 is 0. And ultimately, to know if you get a 0 is when you have a 0 at the end. And so this is good for us because I know that one of my zeros is at x equals positive 2. So since I have a cubic, that means I have 2 other zeros that I need to find. But now I could either continue with my synthetic division if you want to, or this is, since I only have 3 coefficients left, that's a quadratic. So what I could do is I could rewrite it as a quadratic, or you could continue doing synthetic division. And I prefer to switch over to quadratic because I like factoring and it's pretty fast. So the factored form of this, remember, we're looking for what numbers multiply to give me -3 and add to give me -2. So I know that's -3 and a 1 are going to give me those two values. Okay, so x minus 3 and x plus 1. So in order to get our zeros now, remember, I set each one. You always set your factor equal to 0 in order to find the 0, and your 0 is going to have the opposite sign of what your factor is. So my 0 is one's going to happen at +3, and the other one's going to happen at -1. I also want to make sure that I write my answer in factored form. So in factored form, make sure that if you use synthetic division, that when you put it in factored form, you change the sign so that 0 at 2 becomes x minus 2. And then since I switched over to factoring my quadratic, I already have those factors, x minus 3 and x plus 1. It doesn't really matter which order you write them in as long as you write all the factors. And ultimately I want to make sure x times x times x is x cubed. Negative 2 times negative 3 times positive 1 gives me a positive 6. That's a way I can quickly check to make sure that I have the correct factored form of my equation. Now what I'm going to do once I have all of this information is I'm going to plot. I'm going to start with my zeros and then my y-intercept. So I know that I'm crossing at negative 1, 2, and 3. Okay, so I've marked all of my zeros on the axis that I have drawn over here. And now I've also marked my y-intercept at 6. You don't have to mark every single line as long as you get a good grid, basic grid drawn. Now I'm going to take my basic shape. I know I'm going to start low, and I have to make sure that I go through every point. So I'm going to start low and finish high. Okay, and I'm going to start here on the left and go to the right. I have to go through my first x-intercept. The next point I have to cross through is my y-intercept, and then in order to get to my next x-intercept, at some point I have to curve. We don't know exactly where this maximum is, but I'm pretty certain it's not going to happen on the y-axis. So notice I just made a turn after the y-axis, and so now I'm going to go through my next x-intercept. I have to turn around in order to go through the next x-intercept at 3, and then I'm just going to finish going high. And so I'm drawing with the mouse, so I apologize that my lines are so squiggly, but you get the general idea. Okay, so let's go ahead and look at and do the same things for problem number 31. Same rules apply. Okay, so y-intercept again is just going to be the constant value at the end, which is going to be negative 6. This time we're crossing the y-axis down here in the negative region. Our end behavior is based on the lead term. It has a degree of 4, which means the ends are going to go in the same direction, and it's positive, so they're both going to go up, just like a quadratic would. Our possible rational roots are going to be the factors of negative 6, or it doesn't really matter about the negative because we do positive and negative versions. So it's going to be the factors of 6 divided by the factors of 1, which is our lead coefficient. Okay, so I've listed out all the possible roots of 6 over 1. Since everything's over 1, I don't have to worry about the fractions. So there's 8 possible roots at negative 6, negative 3, negative 2, negative 1, 1, 2, 3, and 6. Okay, so now we're going to use these possible rational roots to find our zeros and our factored form. Alright, so I've typed in my coefficients 1, 3, negative 11, negative 6, and I've put them here. So the fact that I'm in a 6, I'm going to try 2 as one of my possible roots, and I kind of feel like maybe let's start with a positive and see what happens. Okay, so generally if your y-intercept is positive, 2 is a good bet to try, or 6. One of those would be probably better. I'm going to start with a lower value. Alright, so remember we dropped down the first term, 1, and then I multiply it with whatever 0 I placed on the outside, so 1 times 2 is 2. Then I add, 3 plus 2 is 5. I repeat the process. 2 times 5 is 10. So 10 minus 3 is positive 7. 2 times 7 is 14. 14 minus 11 is positive 3. And then 2 times 3 is going to be a positive 6. Negative 6 plus 6 is 0. And that's ultimately what we're looking for. Alright, at this point I still have a 4 coefficients, which means I went from a fourth power to a third power, or a cubic, so I still have to do at least one more synthetic division. I know one of my zeros is at x equals 2, so I have to do at least one more before I could rewrite it as a quadratic. So since I have a 3 at the end, let's go ahead and try a 3 over here to see if that works. But I have a feeling that since it's a positive 3, I want to be able to change signs. Everything's positive here. The only way that I'm going to get things to subtract away is if I have a negative on the outside. So I'm going to go with a 0 of negative 3. So again, we're going to drop down the first term, then multiply, and then add. Okay, then I'm going to multiply again, and add. And then I'm going to multiply, and add, and I get my 0. Okay, so now I have the last row has 3 coefficients. That's a quadratic. Okay, so the quadratic is going to be x squared plus 2x plus 1, and I can factor that. Factors that multiply to 1 and add to give me 2, that means they're both going to be 1 times 1 is 1, 1 plus 1 is 2, so I get x plus 1 and x plus 1. Alright, if I solve both of those by setting it equal to 0, I'm going to get x equals negative 1. So let me write the 0, x equals negative 3 from the synthetic division. And then from my factoring I did of my quadratic, I get x equals negative 1. And since it happened twice, I know that that's a double zero. Alright, because special things happen at double zeros. Alright, so now to put it in factored form, let me clear up a little space. Okay, my two factors I got from my quadratic, x plus 1, I can just put, since there's two of them, instead of writing it twice, what I can do is I can square it. And then the zeros I used in my synthetic division, remember, whenever you go to factored form, you have to change the sign. So a positive 2 in factored form is going to be x minus 2. And then the minus 3 as my 0 in factored form is going to be x plus 3. Alright, so now I have enough information to graph my polynomial over on the right-hand side because I found my end behavior, which is my basic shape, my y-intercept, and my zeros. Those are really what I need. The factored form and the possible rational roots are steps necessary in order to get to that information. So I'm going to go ahead and mark over here my zeros and my y-intercept. Okay, so I have over here marked on my axis the y-intercept at negative 3, negative 1, the x-intercept at negative 3, negative 1, and positive 2, and my y-intercept at negative 6. And now what I'm going to do is I'm going to go ahead and add my shape. I'm going to look at my end behavior. Both ends have to point up, so that means I have to start high and finish high. And remember, when I get to x equals negative 1, that's a double zero. That's when I have a tangent point at that 0, which means I'm going to turn through when I get there. So I'm going to start high. I'm going to go through my first 0 that I reach at negative 3, and I'm going to cross through it. I have to turn around to get back to my next 0 at negative 1. And remember, because negative 1 is a double zero, that becomes a turning point itself. Alright, so that's a tangency point. Now the next thing I have to go through is my y-intercept. So I'm going to go down through my y-intercept. And my next point that I cross through is at positive 2, so I have to turn around and go up through negative 2. And then I'm going to finish with my end going up. So I'm going to place my arrows on my graph, and that is what the graph for number 31 should look like.